Okay, hello there guys, welcome back to another LibGDX video tutorial. It has been a while. I've been a little bit busy with work, so I didn't have enough free time to do tutorials. Anyway, so continuing our previous videos, I made a number of improvements off screen, but I'm gonna tell you what did I do here. So first, I took into consideration the way the game is being played, so moving left and right only is not good enough for the game. For that very reason, I changed the input method. So instead of having to move left and right, I created something like a ring or like a disc, and when you touch that, it will behave like analog controls. So let me show you. So this is the display, so you can see here if I click on this part, it moves this one like this or here, and you can see based on your location it can detect the type of input you are, or let's say the angle between your touch and the center of the disc or the ring, and based on that it will set the direction. In addition to that, now the keyboard itself, it can move as well. So we finished that. It's much better than before. So now you can not only move left and right but up and down as well. Now, so I need to explain how did I make this. Okay, so I commented part of the old code. I didn't remove that, but now I'll explain things and remove the code as needed. So the first thing that we need to do obviously is to go to the assets and show you the let me see, bad logic, not this one, game font, where's that? Sprite sheet. So this is the sprite sheet file. Basically I added this ring, I created this using Microsoft Word, just a circle with a border like that. I placed it in here, not something fancy, something very simple. That's fine. Now let me go to the input management. This is the input management class, and let me show you a few things here. So this is the old button class which has information here, no problem. Now I created another class inside this one, input management, which is called button ring, and its job is to identify the touch location on the ring and calculate the required, angle so that the spaceship moves accordingly. So we need to specify the center X and the center Y, and the virtual center X and the virtual center Y. These represent the virtual coordinates of the display, these represent the physical coordinates, and also we have the actual radius and the virtual radius. And also we have alt value indicating that the ring is being pressed right now or not. Okay, the alt value, sorry, and the value which represent the current status. The text is still there, but I'm not using it at all. The visible is used to display or hide the ring. So we have a constructor. The constructor will specify the X and Y, the center X, Y, and the ring radius. So here these are the virtual values, I store them, and based on that I will create the actual physical values. So how do you get the actual center X? So you divide the virtual on the total virtual width and multiply it by the physical width. Okay, and the same thing goes for the Y coordinates, and the same thing goes for the radius. Okay, so if you do that accurately, you will get these values. That's fine. Now let's go back to the important part, which is identifying the actual angle. So you the game engine will send you the X and Y location, the physical locations where the ring is being pressed. So first we need to find the distance and see if the ring is actually being pressed like a because this is a circle, not a square, so pay attention to this one. So what we do is find the distance between the center, the physical center of the ring and the actual touch location in terms of x-axis and in terms of y-axis, and the distance law, if you remember this from math in school, it's square root of delta x squared plus delta y squared, as you can see. Now if the distance is smaller than the physical radius, this is the distance, is the physical distance of the device. If it is smaller than the radius, then you are pressing inside the ring itself. And also I'm checking that dx is not 0, because you will see that I'm dividing by dx in a second. Okay, so now we will calculate the angle. So if delta x is smaller than 0, I will say that the angle is equal math to 2 degrees. We calculate the arctangent of the value minus dy on dx and so on. So this is straightforward. I used a similar formula, if you remember in the previous tutorials, to guide the bullets from the enemy towards the player. Now this one is different. I am guiding, figuring out the angle based on the touch on the your touch on the device screen. Okay, so I find the angle and that's it. Very straightforward. And now let's see, now we are back to the original class. So we have buttons, that's fine, but we will define a ring button here. Okay, so I'll define texture region for ring button, no problem. And the move left and right are not being used anymore, so I am gonna delete them. So okay, because we are not depending on these at all. Okay, so let's go back. This is the initialization here. Now I define the buttons, and this is the initialization for the ring button, the texture itself. I define the ring here, and since I defined this one, I don't need the left and right buttons at all, so I'm gonna remove these. Okay, I don't need to set things for the left and right button anymore as well, and also no need to set the text for these. Okay, so it's very straightforward, nothing much. Also, the list of buttons doesn't contain left and right buttons anymore. Okay, now since I removed the buttons, the left and right button, and I used to add these to the list, and I identify the buttons based on the index itself. I added nulls because I'm not adding the buttons themselves, and the reason for that is that if I remove them, I'll have to go in the game and update all the indices and make sure that every button is in its actual place, actual index. So there is a better way to do that, but I was lazy, so I did it like that. Okay, so I am being lazy here. This is why we have two nulls. Okay, sorry about that. Let's go to the part where we update the status. So this is very straightforward. We are setting the old value here, and yeah, maybe also I might want to say that ring dot old value equals ring dot value. There you go. Okay, so we set the old value and set the current value to false, meaning that all the buttons are not being touched for now. And I am checking if there is a button being clicked and so on. So I'm looping, starting from 2, not from 0, because we have two nulls, right? Okay, for the left and right. Okay, I hope that explains why I did it like that, not from 0 but 2, because there are two nulls. Okay, and also I'm checking that the button is visible and it has not been clicked before. So if it is not being clicked, I will check the touch status and so on. And after I do this for all the buttons, I also check the ring because it has different, status. Check. Anyway, now here I am checking the touch on the display itself. I'm saying here this is 0 to 3, so 4 touch points. Maybe I could increase that, but anyway, it's working fine. So I'm checking if there is a touch. I'll update things accordingly, right? So also starting from 2, checking the touch and the ring, that's fine. And finally I'll check the keyboard, okay, because if you are playing using the keyboard, yeah. So left and right, I don't care about these, okay. Now instead of left and right, I will check them. However, I'm doing this, I'll use TX in this case to indicate the direction in the x-axis and the y-axis based on the keyboard. So we have these. So if the player is pressing the right keyboard, increase TX. If it's the left, decrease TX. So right means +1, left means -1, no button beacon press means 0, and similar thing goes to the y-axis. Okay, now I'm saying if the x or y is not 0 or not 0, okay, so I enter this one. By the way, this part is not needed because you know, yeah, because this will not get executed because this condition is contradicting with this one, right? So let me see, think about it for a second. If this one is not 0 or this one is not 0, obviously these will not get executed. So yeah, so if dx equals 0, this one, yeah. So actually I could right away remove these guys. Right, and so I remove this and also remove this. That's fine. So what do we have? We set the ring value to be true, meaning that we press one of the buttons, if that makes sense, right? And also I will check if both are positive, you know, we have this angle and so on. So I set these angles accordingly. Yeah, so very straightforward. Also I don't need to save these guys anymore. Okay, removing alt code. Now this is the part where we render the buttons, right? So we are rendering the ring first here, and then we are rendering the buttons as well. So something that is very straightforward. Now you might be wondering, so how does this ring input affects the spaceship? So if you go to the player spaceship and go to the update part, where's the update? So this is the update part here, right? So the changes are very straightforward. All I have to do, I would call the, you know, the basic class of update here. Okay, super.update, and that's it. And also I will check and make sure that the player is within the screen. One last thing that where is it? Where is that? Spaceship texture, speed, use angle. Okay, so this one, actually use angle is false, but actually I changed this to true. Okay, I changed this to true at another location. I'm not sure where, but this is why it is using this one right now. Okay, so this is what I do. If we go here, where's the part where you say use angle? Use angle. Yeah, so here you can see use angle equal true. Okay, actually I don't need to set this anymore, right? Yeah, so this is why. And also this is the main file, so I will remove all the extra things that I don't need at all. Don't think I need this one. Also don't need this one. Also don't need this one, and don't need this one. Okay, what also I don't need to set in here. Yeah, we don't need this one also. Let us clean the code a little bit. This one's not needed at all because I'm using the ring, as you can see here, and also this need to be removed, and also this need to be removed. Okay, these also need to be removed. Okay, so now yeah, these guys. Okay, so now let's run the game and just make sure that it's working when we remove these few things. Hopefully this won't be, we didn't break anything. Hopefully. Start the game, no problem. Okay, that's working fine. Use the keyboard, as you can see. That is okay. Awesome. Right? Okay, so this is all awesome. This is all great. It is working fine. So this is basically how we changed our input and change it into a ring, which is far more efficient and much better than before. Okay, yeah, so what do we have to do next since we finished these guys? Oh, one other thing I did is that we assumed that when we are running this game, okay, I will run this on Android emulator. We assumed that it will run on the same speed on different devices. However, I was totally wrong when I ran the game on my phone. The problem was that when we get into collision detection part, the game slows down considerably. You can see the changes frame by frame, and the reason for that is that if you go to the collision detection part, or sprite colliding, first we are creating a very big buffer for collision detection, which is the same size of the screen, and then we are scanning all that, not all that area, but most of that area, which resulted in very slow processing. And to be precise, the part that is causing the problem is this one. This part is getting the image from the frame buffer and convert it to pixmap. Okay, and this pixmap, the process of converting this buffer into pixmap is taking so long. So this is the part that is slowing things a lot. Okay, and this happens twice. It happens here and it happens here. In addition to that, you know, we are scanning this pixel by pixel. So what I did is, first I changed the collision width and height and made it so much smaller. So in this part here, in G01 game file, I created these two variables. Actually they are already there, but I used to give them, you know, I used to set these to 1280 and 800, but instead now I'm just giving the width and height 128 by 128, meaning that the maximum sprite width and height could not exceed 128 pixels. Okay, so this is the first thing, and this as a results in much smaller image to be transferred from the video card into, you know, the game memory, if that makes sense. Okay, so things would get much faster. In addition to that, instead of checking pixels one by one and checking, you know, skipping a pixel. So now this is not very accurate, but it's working much faster and much smoother. But I still need to improve performance, so I'll have to look into that later on. Okay, so let's get to this one. Hopefully if I could rotate this, let's see how it behaves. Okay, so now this one's fine. Let's see. Go. Okay, now so here this one is working so fast actually. Okay, sorry, I need something that will, okay, oh, I can use the keyboard with Android here. That's good. Okay, so here, so this is working faster. This is working very fast, and the reason is that this is using the CPU of this machine. Okay, if we go to performance here, well, you can see that, you know, this machine has 80 threads, which means it can run very fast even in emulation mode. Okay, so this is why you cannot depend entirely on emulation. If you run this on your phone, you will find that the performance is slightly slower, especially when the bullets or sprites try to hit you. Okay, so you have to pay attention into that. Okay, anyway, I just wanted to explain this because it's important to notice such things. In the end, you have to test against physical devices and see the performance of the game. Again, this is not the best way to solve things the way I did it. This is, you know, let me see, shut down this. Yeah. So basically, this is not the best way to solve things by making it less accurate. We will have to improve this. Now, one of the ways that we could improve the performance here is that instead of rotating the sprites at runtime and rendering them into buffers and then copying the content of the buffers from the video card into the game memory and then checking pixel by pixel, is to create a very big in-game buffer where we take each sprite, rotate it in all possible degrees, okay, and then when we are matching, we could go to the correct buffer, okay, which is pre-rendered and stored in game memory, and match them right away. It will require some amount of work, but the result is much faster execution, because we won't need to rotate things again. We just do it once and everything will be stored in game memory, so there will be no delay to transfer from video card memory into the OS memory and then accessing pixel by pixel. We could even change this into small bytes, no small bytes, I mean bytes, okay, which represent there is a pixel or not, instead of having to store the values as RGBA, which would make the game much slower in checking collision detection. Okay, maybe we'll do this later on, but for now these are the important changes that I made to the game. Hopefully we will work on weapons. I know I delayed this number of times, but you know, patience. Hopefully we will get you know, better performance and better gameplay. That will be all for today. Thank you for watching. Have a nice day. Bye bye.